Hello everyone and welcome back to I'm Technos. In today's video, we are diving into Amazon Bedrock, where we will explore the model catalog, see how to test models in the playground, and understand high-level concepts of fine-tuning and RAG, which stands for Retrieval-Augmented Generation. Plus, we will check out how Bedrock supports responsible AI with built-in security and watermarking features. So let's jump in. With Amazon Bedrock, you can instantly access foundation models from top providers like Amazon, Anthropic, OpenAI, Meta, and more, all with just a single API request. There is no need to manage infrastructure. You can easily integrate Bedrock with other AWS services. Now, let's take a look at the model catalog inside the Bedrock console and explore what's available. In the Bedrock dashboard, under Discover section, select Model Catalog. This page provides complete overview of all foundation models available. This is where you understand their capabilities and choose the one that best fits your use case. Here, you can see models from different providers like Amazon, Anthropic, Meta, Mistral, and more. Each provider brings unique strength, whether it's a text generation, reasoning, or image creation. You can also find serverless model access status and tells you which models you can use immediately, which you can request, and which are completely unavailable. And marketplace deployments in Amazon Bedrock offers access to a wide range of models, but they require manual setup and management. They are ideal if you need more control or customization, but they aren't as fast or easy to use as serverless models. Under modality, you can filter models based on categories like text, chat, embeddings, or image generation. This makes it easy to quickly find the type of model you are looking for. For example, if you select text, you will see all models from different providers that specialize in tasks like summarization, content generation, document analysis, or question answering. And on top of it, clicking on a specific model shows you details like its description, supported use cases, token limits, languages, and key parameters. This makes it easy to understand which each model offers and compare them side by side before choosing the right one. Once you have explored the catalog and selected a model, you can test it directly in the playground by clicking Open in Playground at the top right corner. As you can see, Amazon Nova Micro is selected. Simply enter a prompt such as define AWS and then click Run. It quickly generates an output showing its components. You can also control the output by choosing different options in the left navigation, such as first we have mode. You have two choices here. Chat mode is a multi-turn conversation mode where the model remembers previous inputs in the session, whereas a single prompt mode is designed for one-time standalone completions. The model sees only what you enter. It has no memory of previous prompts or its own outputs. Next, we have system prompts. This is where you give the model special instructions to set its model's behavior throughout the conversation. For example, you could say you are an AWS trainer. Think of it as a presetting the model's tone, role, or context before any user input. Then we have maximum output tokens. This simply defines how long the model's response can be. By default, it's 5 to 12 tokens. Now, one token is just a small chunk of text. It could be a word, a part of a word, or even a punctuation. Roughly, 100 tokens equals about 75 words. If you want longer answers, you can increase this limit, say to 1024 tokens. Another setting is stop sequences. A stop sequence is just a marker that tells the model when to stop generating. For example, if I set end as a stop sequence and click add and ask the model to list AWS services, it will stop as soon as it outputs the word end. Sometimes the model generates the stop word naturally because it predicts text to one token at a time. The moment it hits the stop sequence, Bedrock cuts off the output. Now, in this case, the output didn't stop at end. It stopped because it hit the maximum output tokens limit. That's another way Bedrock controls length. Here is another example. If I set and as the stop sequence and ask the model to list AWS services, the moment it outputs the word and, Bedrock stops generating, as you can see here. So the trick is to choose a word or symbol that won't normally appear in regular text, like stop, hash, or even special tag. This is super useful to keep output short, clean, and structured, especially for APIs, chatbots, or structured responses. Now let's talk about randomness and diversity. Here we have two key settings, temperature and top P. Temperature ranges from 0 to 1. That controls the creativity of the response. Lower values like 0.1 makes the model very predictable and focused. Higher values like 0.9 make it more random and creative. And 0.5 gives a nice balance between the factual and creative. Top P, also called as nucleus sampling, works a bit differently. The model predicts the next word by looking at probabilities. With top P, it only considers the smallest set of words whose combined probability reaches your chosen threshold. Suppose the model is predicting the next word and the probabilities are as shown here. If top P is 0.7, the model takes only the top words until the sum of probabilities is greater than or equal to 0.7. That means cloud, which is 0.5, plus server, which is 0.3, is 0.8. So it only considers cloud and the server. Then it randomly picks between them. So adjusting temperature and top P together helps fine-tune output style. Next, guardrails. This is all about safety and content moderation. You can enable guardrails to filter out toxic or unsafe outputs. Bedrock even lets you choose different levels like strict, moderate, or custom. This is really important when you're building production or customer-faced applications. Then you have prompt caching. If you enable this, Bedrock can reuse results from earlier prompts. That means faster responses and lower cost during testing or development. And finally, reset all to default. If you tried out a bunch of custom settings and things don't look right, just click reset and everything goes back to the safe default values. Another feature in Amazon Bedrock is model evaluation. This lets you test and compare different models so you can choose the best one for your use case. To do this, simply enable compare mode. Then pick the models you want to compare. But remember, they must have the same modality. That means text models should compare with text models, image models with image models, and so on. Otherwise, you will end up with a bad request error. For example, here I have selected Amazon Lite on the left and Nova Pro on the right. Now, if I enter a prompt like explain cloud computing in simple words and click run, you will notice that both models generate different styles of responses. This helps you see which one better fits your needs. You can also do the same thing with image models. Just click select model, go to Amazon category and choose Titan image generated G1. Set the number of images to 1 and enter a prompt like a cat sitting on a laptop and click run. You can see an image is generated and you can even download this image. Now give the same prompt to the Nova Canvas model. Set the number of images to 1 and run the same prompt. An image is generated and you can compare the outputs. So by experimenting with different prompts and settings, you will quickly figure out which model works best for your project. There is also another interesting feature that shows how Amazon Bedrock supports responsible AI. Bedrock automatically adds a watermark to images generated by its foundation models. Though right now, this is supported only for Titan Image Generator and Nova Canvas. To test it, just click Choose Image, upload one of your generated images, and hit Analyze. If the image came from Titan Image Generator or Nova Canvas, Bedrock will detect the watermark, as you can see here. But if you upload any other image, like one downloaded from the internet, and hit Analyze, it will simply say watermark not detected. This way, not only can you evaluate and compare models, but you can also trust that Amazon Bedrock is built with security and responsibility in mind. With a model in action, it's clear how easy it is to interact with. But beyond just running prompts, Bedrock provides powerful capabilities like fine tuning. Fine tuning lets you customize a foundation model for your specific use case. Let's walk through the process step by step. Step 1, choose your foundation model. Bedrock gives you access to multiple foundation models like Amazon Titan, Cohere, or Anthropic Claude. The first step is to pick the one that best matches your use case. Maybe you want text generation, summarization, or classification. Step 2, prepare your training data. This is the most important part. You will need input-output pairs, basically examples of prompts and the exact responses you want. For example, let's say you're building a customer support bot. If a user asks, how do I reset my AWS password? The bot can respond with, you can reset your password by going to the AWS console login page and clicking forgot password. These examples teach the model how you want to respond. Step 3, upload your dataset to S3. You save the dataset in JSON format and then upload it to a S3 bucket. That's where Bedrock will pick it up from. Step 4, create a fine-tuning job. In the Bedrock console or through the API, you select your foundation model, point to the S3 dataset, and configure the job. Bedrock handles the heavy lifting like training and optimization for you. Step 5, training and evaluation. Bedrock now runs the fine-tuning job in the background. It uses part of your data for training and part for validation, so the model don't overfit. You can track progress and check metrics as it runs. Step 6, deploy your custom model. Once training is done, your fine-tuning model shows up in the Bedrock console as a custom model. And the best part is, you can use it just like any other foundation model in the playground or directly through the API. Step 7, test and iterate. Try out prompts with your fine-tuned model. If the answers aren't exactly how you want them, refine your dataset and run another job. Each cycle makes the model smarter for your specific use case. And that's it. Fine-tuning in Amazon Bedrock is all about taking a general purpose foundation model and making it work smarter for your business, whether that's healthcare, finance, retail, or customer support. Fine-tuning is suitable for small, stable data sets that are very domain-specific and when there is a need for task-specific behavior with controlled outputs. However, if the data is constantly changing, or if you have large knowledge base and need quick deployment without retraining each time, then RAG or Retrieval-Augmented Generation is the better choice. It's a technique where a foundation model does not rely on what it was pre-trained on. Instead, it retrieves relevant information from your own data sources at query time and then uses that information to generate a more accurate answer. Here is how it works. First, take your documents like PDF, FAQs, or knowledge bases and convert them into embeddings. Next, store these embeddings in a vector database like OpenSearch or Pinecone. Then, when a user asks a question, the system fetches the most relevant chunks from the database, which are called the context. After that, the system combines this context with the user's question into what's called the augmented prompt and then sends it to the foundation model in Bedrock. The result is a response that's not only smart, but also accurate, up to date, and perfectly aligned with your business needs. For example, if a customer asks about your refund policy, without RAG, the model might just guess. But with RAG, it looks up your actual company policy and gives the exact answer. The best part is that no retraining is needed. You just connect your data and the model handles the rest. That's RAG in Amazon Bedrock, combining the model's generative power with your own knowledge base to get the most accurate results. While providing a range of capabilities, it also maintains enterprise grade security. Your prompts and responses remain private. They are never shared with model providers, never used to retrain foundation models, and can only be accessed within your AWS account. All data is encrypted both in transit using TLS and at rest. With IAM access control, you decide who in your organization can call which models. Bedrock also compiles with major standards including DGPR, HIPAA eligibility, SOC, and ISO certifications. For network security, you can use VPC endpoints to ensure that model calls never travel over the public internet. Logging and monitoring are built in with CloudTrail capturing all API calls for auditing and CloudWatch tracking key metrics like usage, latency, and errors. Finally, you can enable content safeguards such as guardrails to filter harmful or unwanted outputs. That's it for today, and there is no cleanup for this demo. If you have any questions, feel free to drop them in the comments below. Thank you for watching, and I'll see you in the next video. Take care and happy learning.